Hello, everybody. Welcome to OpenCV Live. My name is Dr. Sacha Malik. I'm the CEO of OpenCV.org. And today we have a very exciting episode for you. We have our friends from Rerun, and they're going to show us tools that enable you to visualize data. And if you look at embodied AI or any kind of 3D data visualization, it's crucial if you want to train models or do anything with that data to be able to visualize it, to be able to manipulate it and see it in real time when you're working with this kind of data. And Rerun has the best tools available in this domain. So we have two people from Rerun, Nico and Pablo, who are going to show us various things about the new updates in the Rerun tool. And as always, we also have Phil Nelson, who is the director of content and creative at OpenCV. He produces the show. If anything goes wrong, it's his fault. Hi, Phil.
Yes, hello out there, everybody. Let's go Blue Jays. One more game to beat the Dodgers. Beat LA. Beat LA. I am your co-host with the co-most, the second banana, who's second to none. I'm also your plus one and only. It's Mr. Nelson, if you're nasty. But you, my dear friends, can call me Phil. And I'm here to remind you of something that we do on every single episode of this here program, which you're watching right now. The first of which is a special giveaway to you out there in the audience. Stay tuned. Later on in the episode, I will be asking a trivia question based on the presentation from our illustrious guests, Nico and Pablo. And the first person to answer that question correctly will win the OpenCV University course of their choosing. You can see what courses are on offer by going to opencv.org/university. There's also some freebies out there, the OpenCV Bootcamp, etc. So it's not all just for pay, but even if you don't win today, invest in yourself, invest in your career, learn something new with OpenCV University. We're also taking questions from you in the audience. Use the Zoom Q&A button to ask your question at any time if you're watching on Zoom, or if you're watching on any of our other channels such as YouTube, LinkedIn, or Twitch. Just post your question in the chat wherever you're watching. I'm monitoring those, and I will pick out the best ones to bring up on screen during the show. Like, for example, our friend Benny Jackson here on LinkedIn just did a repost of the live session, hoping somebody finds it. Thanks, Benny. We appreciate you. If you do and say cool stuff in the chat, I might put you up on screen here. And later on in the episode, we'll do that with the best questions from the event here. Before we get started proper, though, I think, Satya, let's me and you briefly talk about what we did on our summer vacation here. We had a so I was at PyTorch conference last week, and that was an interesting one. It was at Moscone West. Ran into some folks out there that big OpenCV fans, big users of OpenCV, and so that was exciting. But this week we were in Fort Mason here in San Francisco for OpenCV Universe. We were part of the open source zone at OpenCV Universe. Satya, can you spend a minute or two talking about what OpenCV Universe was like?
Yeah, GitHub Universe, you mean?
Sorry about that.
Yeah, it was really nice. It was a conference of open source organizations organized by GitHub, and we met people from Homebrew. We met people from many open source projects that we love, and it was in the best part of San Francisco, a beautiful, beautiful place. So we learned a lot, like how these organizations, how they fundraise, and we were glad to know that everybody suffers from the same fundraising challenges that we do. So if you are able to support open source in general, please do so, because all organizations we met, they have challenges raising money, except for the ones that who claim to be open source and are actually not.
Yeah,
So yeah, it was a great
we're looking at you, Mr. Altman. It was a lot of fun. Yes, thanks. A big shout out to Greg Cochran, who was kind of the leader of the GitHub Secure Open Source Fund, which OpenCV was also a part of. And yeah, shout out to Lee, who put together the open source zone over at Universe. That was a lot of fun. And we so hopefully we'll be back next year for GitHub Universe as well. So let's see. I'm going to go ahead and bring our guests back on screen here, and we can chit chat no more and begin with the presentation. Nico, Pablo, why don't you guys introduce yourself to the audience, and then you can go ahead and do whatever screen share you want, and I'll bring it up on screen. I'm going to drop me and Satya off the screen right now, and but you can still hear us.
Awesome. So yeah, once again, thanks to be here. I'm Nico, the CEO of Rerun, and I have brought with me Pablo today. So Pablo's actually not part of Rerun, but I think the most fun way to demo stuff is to have a real user of a Rerun, kind of show how sort of real example how Rerun can be used for real. So it'll be really fun to invite Pablo. He's been a partner of ours for a long time, helped us out just sharing some cool stuff that he builds so on social, so on, and is also building a cool company around robotics data. So maybe probably want to introduce yourself. I guess I already did, but yeah.
Yeah, well, I'm Pablo. Yeah, we've been partnering with Rerun for a while now, and really using the tool as much as I can and showing what's possible with it. And the main thing that I'm working on right now is how to collect large scale human-centric data for robotics trainings. So the goal eventually is to use this data to help train robots. It's the best and most scalable version. So that's basically what I'm doing, and Rerun's been a absolute critical part of that. So
cool. Okay, awesome to have you with us. So today, I have a little presentation. I thought I'd walk through that. It's we'll do that first. Go through the slides. I thought I'd talk about that Rerun is in fact quite a bit more than visualization. It's really be talking about data infrastructure quite a bit. And but of course we love visualization. It's super core to Rerun, and so there'll be a bit of that too. And I'll just rearrange my windows and things.
Yeah, hide anything that needs to be hidden.
Exactly.
I do not want to have to spend time editing this show.
That feels like, there we go. This feels like the right window. Okay. Yes.
Vibe streaming. Okay.
Is this one?
Do that.
Share this tab instead.
Oh, hang on. That's not it.
How about this?
Here, no, bottom.
This is about right.
Here, let me find it. I see it. Yep, I got it right here. And I don't know why it's doing. Okay, I'll fix it.
We have it up?
There we go. It's up.
There we go. Fantastic. Okay, so yeah, I'm here to talk a bit about Rerun, the physical data platform. Let me just see if I can make this thing move. There we go. And so I'll get into the why and everything, but just to sort of level set a bit, so Rerun is where we build two things: an open source SDK for logging and storing, querying, and obviously vision, multimodal and multi-rate data. We call that physical data. It's the kind of data that you'll have in robotics, spatial computing, basically whenever you're trying to build some intelligence for the physical world. And then we also build a commercial cloud platform, just providing unified data infrastructure for you iterate super fast on robotics learning. Just make sure you learning work and get to the market faster than everybody else. And me, I am co-founder, CEO of Rerun. I used to be a computer vision and machine learning engineer, and spent about a decade before Rerun building products for the physical world. So this is really just my passion project to my past self, much more productive, and excited to be helping the community with that. All right, this is the core of our belief, and why we started Rerun, is that I think physical AI will reshape the world's economy, and just has a shot at making the world just like an incredibly better place. And so that's why we're here, to just accelerate that. And the problem though is that working with this physical data is just way too high friction. And robotics and these kind of tools is high friction and difficult enough, and we can't have any unnecessary friction if we really want to make this happen. So something that it's true across AI, sort of LLMs and sort of all of these different areas is that the teams, they just iterate super fast on the modeling together. And that to do that, you need sort of super fast, low friction, and like easy to understand and observable data infrastructure. And the reason for that is because you need to iterate on the data and the modeling together. That means that at the end of the day, it's really like the researcher who is needing to both edit data pipelines and sort of mixture with what data is coming into the models and change the modeling, right? And to make that be actually practical, this needs to be just super low friction. So it's worth asking kind of what kind of data infrastructure is available for the sort of best LLM labs in the world. Like what do they have? And so on the data storage side, they can use sort of these columnar storage engines that are built for super large scale tabular data. They can use things like OpenStandard and Iceberg to store and work with that data, manage it, and sort of basically in on cloud platforms and flexible and easy to work with. To query data, to explore it, they can use robust, super large scale query engines and sort of processing engines, sort of declarative APIs that just make it super easy to understand and transform their data. And they can look at their data as much as they want. Right? It's trivial. You can just text usually, so you can just read it. You don't have to do any processing. If it's something other than text, it tends to be simple numbers and things like that, where you can just plug it into normal visualization tools, and that just works sort of out of the box. So it's really easy to sort of store, transform, and look at your data as much as possible. And so that's what's available to those teams. Core factors that lets them like really ship like incredible models really fast. And so that's worth asking, like, what is available to the teams in building physical AI, particularly that are not using Rerun. And so here is no real storage format that is built for reading and flexibly working with this sort of physical data, like robotics data, both efficiently for like analytical queries and in a low friction way. So the community tends to be using formats that are optimized for writing, really like logs, robust formats like ROSBAG and MCAP and things like that. Really great for that, but not meant for large scale querying. On the query processing side, there basically is no real query engine out there broadly available that works effectively with robotic data. So teams end up having to write custom imperative code to do like every data transformation. You just read these log files into memory, write some code that transforms it and writes it to new files. And on the data exploration side, or data visualization and all those kind of visual tools, same thing there. There are some point solutions visualizing log files, for instance, but in general, it's a lot harder to visualize and understand this kind of data. You end up with 3D and video and like combine that, synchronize with series and so on, and just it's a huge investment for teams to keep consistent and like easy to use tools there. So the situation is honestly pretty dire. And so basically, physical AI needs to upgrade its data infrastructure like all the way through if we're gonna really make this like exciting future happen. And so the core of that is basically physical data is different from tabular or document data. If you think about tabular data, it's really easy to store it and keep it organized or rows. There's been done for decades. There's like a lot of research and great infrastructure around that, and it's easy to think about and query. And because it's text oriented or simple numbers, it's easy to visualize it. Physical data, on the other hand, is multi-rate, multimodal, and sort of generally like very hard to query. So multi-rate, that basically means that you tend to have if you think of a robot, you'll have a lot of different signals coming out of a robot that are not aligned perfectly in time. Your video sensors are running at 30 hertz. Your motion sensors at 500 or 1,000 hertz, and then you'll just have a lot of internal data that will end up not coming in all at the same time. That's just how these systems end up having to get built, and that just makes the data tools like very, very different, and it makes it very hard to plug this kind of data in tabular data, right? And yeah, the visualization, of course, is way more complex. So that just means that you cannot use effectively the kind of big data tools that we have. And then that problem is actually made a lot worse recently with the move towards end-to-end learning. So in the olden days, we used to use like classic methods only, just pure code to kind of try and understand the physical world with computer vision or other methods. And over the last decade or so, it's moved into combining that with sort of running a bit simpler models. And those tend to be just maybe taking one image or a little image plus some metadata, running it through a neural net and outputting the result. But it's a frame-to-frame kind of model. So you still have to combine those models, like say an object detection model, with a bunch of other code. But then as we move to training more of our systems end to end, our data systems that we need to use to create the data sets to train on end up having to have keep track of sequences transforming to other sequences. And for text, that's still relatively simple, but if we're talking about robotics data, now that gets a lot more complex.
I feel like you could just make a T-shirt out of the title of that last slide, and end-to-end learning makes the problem worse.
Yeah, it's definitely something like a devil's bargain.
That'll be the new
it does
Rerun
make things
shirt.
work. Well, I mean, we're here to help, so I guess then Rerun makes it better again. Something.
Yeah,
like
there
that.
you go.
All right. So just to kind of dig into that a little bit, if you think about like simpler models, they allow simpler data infrastructure. If you think about just this model that has one frame as input, one frame as output, you can actually store a table of these samples in fairly regular tabular format, right? Maybe you have a row and that has a couple images, some text, and a bounding box, something like that as your input, or maybe the bounding box is the output, and you can store that as a row, and it kind of does fit into the normal model. But to end-to-end models, you're really thinking about this sequence of history that you're giving the model as an input. And for a lot of the modern robotics, like vision, you'll be outputting chunks of future predictions, future actions. And so you really have this sequence-to-sequence problem, and that just makes things so much more complex. Dig into that a little bit more. Might have a sort of say some kind of action chunking model here. We can think of that. So you're giving it this window of history, and so you need to store somewhere episodes, like things that happened, like a recording of some what. And at any given time, you may be feeding the model a set of history there that the model is done using to predict some things it should do given this history, these things that have happened. What should it do in the future? But you're not necessarily sampling the history as just like they say 15 previous timeframes. You may want to keep track of what happened a little bit further back in time, and so that's up to the modeler to decide how you're sampling history. But then you're increasing that hyperparameter, or like how you choose that also increases the complexity of how you're feeding it data, right? Because now you have to keep track of everything being correctly ordered on time and the spacing backwards and things like that. you're going to be doing the same thing forward in time, because when as with much training, if you're doing some supervised imitation learning, for instance, you'll also have saved the future actions, like what is supposed to happen in the future that we predict. And so then you're sampling that forward in time from your data sets. Again, sort of increasing the complexity. And when you train models, this is sort of the error. You could be error and train on top of that.
Process starts with a
I think there's like a video in there.
process starts with a process starts.
Sounds like techno.
Yeah. So let's see if I can like turn off from a video from an old. I guess I haven't tried this video. How am I going to get around this one?
Process starts with a teacher
Can you hear
demonstrating a small set of skills through teleoperation.
I can also hear
Then,
a video.
our AI-based diffusion policy learns in the background over a matter of hours. It's common for us to teach a robot in the afternoon, let it learn overnight, and then come in the next morning to a working new behavior.
Anyways, so let me just go back again here for a second. So we want to train a model that has this like complex input and output sequences.
Process starts with a teacher demonstrating a small set of skills through teleoperation.
Goal, but
then, our AI-based diffusion policy learns in the background over a matter of hours. It's common for us to teach a robot in the afternoon, let it learn overnight, and then come in the next morning to a working new behavior.
Use to produce battle models, right? So we're going to be recording robot-rated or real. We're going to try and figure out like what the right subset of that data is to train on, to really get it in the right shape for training. Use that to output some models, and then sort of use those models to create more intelligent robots in the real world.
Process starts with a teacher demonstrating a small set of skills through teleoperation.
What's going on?
Then, our AI-based diffusion policy learns in the background over a matter of hours. It's common for us to teach a robot in the afternoon, let it learn overnight, and then come in the next morning to a working new behavior.
Upload it. You might run it through some data cleaning. That data, that means like running time alignment and sort of extracting only the features you want to train on, and having it maybe things like extracting embeddings and other things like that, and then using those to like select the right subset or curate your data, and then put it into a physical format that makes it really efficient to train on. You'll train, evaluate, deploy. That's the one way, like one pass through to use some new data and have it create a more intelligent robot, hopefully.
Process starts with a teacher demonstrating a small set of skills through teleoperation. Then, our AI-based diffusion policy learns in.
I got it. I just totally muted your screen share. I found it.
Different data sets that are out there. So those need to be super flexible. They need to be very low friction, and you need to have visualization for all of these steps. You could be having problems or bugs or things you need to understand deeper anywhere along this chain, and that's super crucial, and these are built in by default. Okay, and so the traditional data platforms are basically very poor fits for physical data. So you think of data platforms built around stuff like Spark or Apache Spark or Trino, things like that. They have no visualization for physical data built in, so that makes like everything you do like very hard to debug. They're designed for large scale, like preparing data from large scale, like sort of enterprise data, really, where the biggest problem is these complex joins over time. And robotics, we don't have that problem really. So robotics data pipelines tend to be super parallel and have different difficulties. So you actually don't get a lot of the strengths from those like well-tested and like mature data platforms. And the storage itself is not built for physical data. They only support these like dense tables or documents or so on, for not built for these multimodal and multi-rate data sets that we have in robotics and spatial computing. So that's what we're doing at Rerun. We are building data infrastructure that's purpose-built for physical data, and that we're doing it at the whole stack. So Rerun is famous for our visualization, but we also build tools for querying and transforming data, ingesting, storing, retrieving, kind of just everything you need in a data platform. And basically, you can think of Rerun open source as having all the same pieces as the commercial offering. It's just meant for laptop scale data, and that's something we want to always make be the case. Rerun is licensed under MIT and Apache 2, and that's just free and available for the community. And then if your data is approaching sort of cloud scale and you have some of those needs, then you can use the same Rerun SDK just with a different data backend that will scale to large amounts of data. It's in private beta as of right now with a couple fantastic companies, but in the meantime, the open source is available to everyone else. So I'm not going to talk about all the commercial platform things today, because I think that's not available to everyone, and so I want to make sure we're talking about things that are available right now, or at least very soon. So then I'm going to focus on the open source parts. So a core one there is our file format, actually. So we offer the RRD file format, which is a new file format built for this like episodic, multi-rate, and multimodal data. So that's at its core, it's built around a really important abstraction, which is we call them column chunks, but they're really column row chunks. So that is taking something like a robotics recording and breaking it. If you think of a recording as a large, like in your mind, you think of it as a huge table. Every row is what happened on a single timestamp, like a single point in time. And for instance, one column could be an image. It could be the joint angle of the left arm, gripper velocity, whatever you want to put in there. And then so we actually store that data. That data gets stored. A subsection of rows and a subsection of columns, and that data gets stored in a sort of columnar, like as a set of columns within that. So this is basically a chunk of data, which is different than for instance Parquet, where you'll have every chunk of data in Parquet is called and there you'll have sort of every column being part of every row group, which makes it a lot easier to process, but very inefficient for. So instead, we built a lot of tools to make it really easy to process this kind of the data that's stored in column chunks, and that really unlocks like a much more easy to use and efficient storage and flexibly sort of manipulating this kind of physical data. And yeah, basically from the ground up designed for this kind of data that it took us probably 2 years to really get to this design, and it came really wanting to make the open source visualizer super fast and work really fast for both these like super small data, like a really fast time series, and where you have data where you maybe have one huge point cloud or one huge image, and you can abstraction lets you tailor the storage to fit both of these really well, and to be sort of build fast queries, which things can give out really fast and easy to use visualizer. So that's where that came about, but we're using it much more broadly now, and recommend to at least check that out if they have these needs. And coming some queries like query APIs like this in open source right now, but we're enhancing that in a couple of upcoming releases. Now is an open source data server, which is like Python data frame queries over physical data sets. So you need to do that. You need to have a good time alignment query engine. So you can take all these chunk data stored in say RDs or other file formats, and really fast do time alignments. So you can, for instance, get what is the latest version of all the data for a single piece of time or a single timestamp, And you need to have those kinds of queries to pop of these sort of column row chunk storage formats. So that's built into this query API. And write normal Python data frame queries on top of data sets of this kind of episodic robotics data. And you can query sort of metadata about episodes and also into queries, into the episodes. It makes it significantly easier to do things like query for episodes where Gripper didn't open, and send me the sort of and return links only to those episodes, and then you can send that table of links back to the visualizer and use that to click around and like dig deeper. You can really build some super powerful interactive workflows like that. And so open source right now, but this is going to be coming soon. And this is what we're doing here, is basically that we're developing these features for the commercial product, and then we're bringing them back for the open source community as well as they grow a bit. And I think, if not most, and very importantly, the open source visualization. So we designed Rerun from the beginning to be the whole data life cycle. We want to be incredibly easy to like flexibly prototype like what you're doing in a little like a Jupyter or in a quick Python script that you have, and it should just be super light to visualize and understand it over time. There, you can use it to sort of complex system observability dashboards that you might see in robotics demos of different, or self-driving demos of different kinds, as well as building your own custom annotation tools or curation tools or things like that. So like really using it to unify your visualization stack. And yeah, I won't belabor this too much, but at this point, Rerun is become popular in the community. It's used by I'd say at this point most of the best teams in physical AI in the world. There's some which many of them have put out some open source projects that use Rerun. So here's a couple examples, like the robot from Hugging Face. There's Brush from DeepMind Lab. With Meta, they have the Project Aria. NVIDIA's, for instance, put out PyQV Slam. So it's used quite broadly. But you could check out our social accounts if you want to see just a huge list of like different community members that are building really awesome things with Rerun. So that's most of the base content for everybody. Let's see, I don't know exactly how we're doing on the okay. So the next,
we're good. Definitely.
We do a little demo with Pablo, and unless we want to stop for questions here, but demos are fun. So I'm gonna
let me bring our boy Pablo back on screen. Pablo, you should go ahead and be there on screen now.
Yep, looks like it.
Cool.
I'm gonna press stop sharing, I think.
Yeah, I can just take your screen off. There we go.
Yeah, let me go ahead and share my screen so you guys can see what I'm doing. So
well, actually, here we can go ahead and pause for a moment, and we will take this moment to do our trivia giveaway, and then we will do the demo. So, folks, if you need a reminder, or if this is your first time watching us on wherever you're watching us, one of the things we do here on OpenCV Live is give away something to you in the audience. I'm about to ask a trivia question based on today's presentation, and the first person to answer it correctly, either in Zoom, in Twitch, on YouTube, or on LinkedIn, will win the OpenCV University course of their choosing. You can see what courses are on offer by going to opencv.org/university. I'm going to go ahead and share my screen here, and you can take a look at what is going on with OpenCV University right now. Satya, we've got some promotion going on OpenCVU. Can you walk the people through it a little bit?
Yeah, we have a spooky deal. Halloween is here. We have our Halloween sale. It's 30% off on all programs and courses. Programs are collections of courses, and we highly recommend them because you can get a great discount when you buy a bunch of courses together. And I would highly recommend the Computer Vision and Deep Learning Master Program. This is a collection of all our courses. And it comes with, first of all, it's a heavily discounted price. In addition to the Halloween discount, because you're buying all the courses together, it's discounted, and there are a bunch of freebies that come with that program as well. You also get enrolled to something called Career X for people who are looking for a career in computer vision and AI. Once you have completed 2 of our courses, Fundamentals of Computer Vision and Image Processing, and one of the deep learning courses, which could be deep learning with PyTorch or deep learning with TensorFlow, you get and you have to score above 90% in those courses. We help you get a job, right? It's not a job guarantee program, but it's a job assistance program. So with the CVDL Master Program, you get all these goodies. So please, it's the discounted price is really nice right now. So grab it while it lasts, and that's pretty much all about the Halloween sale.
Yes, thank you, Doc. Invest in yourself, invest in your career with OpenCV University. Before we get to trivia, a little reminder, OpenCV is an open source computer vision library created by a nonprofit organization, and as such, we depend on the support of our members and partners, one of which is with us here on the show today, Rerun.io, a OpenCV member for several years now. We appreciate their support, but they're also joined by ARM, RunPod, Intrinsic, FutureWay, JetBrains, RoboFlow, Hackster, Seventh Sense, Google's Summer of Code, OpenMV, Orbic, the British Machine Vision Association and Society for Pattern Recognition, Tangram Vision, Amped Software, Intuitivo, Rerun, Edge AI, Vision Alliance, and Big Vision, because every company needs a big vision. If you want to be as cool as these companies here and your company uses OpenCV, even if you don't, I guess, please send an email to phil@opencv.org and we can talk about how to make you an OpenCV member. OpenCV has a robust membership program for companies of all sizes. And also you get the good feeling in your heart of giving back to open source nonprofit software. One of the ways you can support OpenCV as an individual is by going to github.com/sponsors/OpenCV or going to github.com/OpenCV and clicking sponsors. You can support OpenCV for just a couple of bucks a month. We've got 16 sponsors over there. We really do appreciate all their help. Mohammed Hassan, Jesse Moses. We got a couple new ones this week. Live Peer, the homies at RoboFlow, DJ Greenwood, Alexander Voronov, Big Vision. Thanks, Satya. The friends at iPop, Comet ML, Jonas Heinle, Alexander Ismailov, Tala Hussein, Nick Libertini, Blue Jay, Ritus Laboratories, and Kujan Totemex. Hopefully I got that one right. Thank you for backing us over on the GitHub. Other things you can do include going to opencv.org/support and helping us out there. There's a bunch of ways that you can support OpenCV, one of which is by buying some merch. We have OpenCV merchandise. We got stickers, t-shirts, hats, pins, and buttons over at the official OpenCV merch shop on Spreadshop, opencv.myspreadshop.com. So now is time for trivia. Now is the time of monsters. Before we do that, though, I would like to big shout out for the OpenCV, our participation at the GitHub universe. They gave us these awesome badges that have like a Raspberry Pi, like an RP3050 or something in there, and like a screen and a little battery. It's super awesome. I'm going to spend a little bit of time hacking on this thing. Maybe we can get a camera and a couple of small OpenCV functions running on it. Just had to bring that up because I think it's probably the coolest badge I've ever seen from a conference. So thanks a lot, GitHub. The way this works is I'm going to ask a question. You are going to answer it in the chat. If you've won in the last couple of months, please don't answer and give someone else a chance to win out there. I've got the Zoom, YouTube, Twitch, all the chats up right here so I can see who answers first in the chat. If you're on Zoom, make sure that your messages are set to everyone and not just hosts and panelists. So a little bit earlier, we've talked a bit about embodied AI today. And one of the things we talked about was some robotics, including the Le Robot project. What company is in charge of the Le Robot project? What company is in charge of that project? Who is it published by? What fancy, famous website? Spelling counts, Leslie Ann. You're so close. Hey, there you go. You got it. Okay. Our winner this week is Leslie Ann Jurawan. Leslie Ann Jurawan over on Zoom. The answer we were looking for was Hugging Face. Hugging Face is the company behind the open source project, the robot arm project, which are pretty cool. And we've been seeing these a lot, Satya. Wouldn't you agree? Like I think it's the project has actually been pretty successful. I mean, obviously, Le Robot has a whole lot of cultural cachet because, like with Hugging Face, just a lot of cultural cachet at the moment. But
Yeah,
I feel like we're seeing a lot of Le Robot.
Our other sponsors, FutureWay, is also involved. I don't know at what capacity, but they are also involved with the Le Robot project.
Very cool. All right. So now I think, Pablo, take it away. Let's see a Brave live demo.
Yes.
We're still looking for a sound effect for the Brave live demo, but we'll get there someday.
Let me share my screen with y'all.
You go right
let me
ahead.
make sure. Can you guys see this? Okay,
Yes,
it should just
indeed.
be a
I'm
black
bringing it up.
screen.
Oh, it's very tall, Pablo. It's very tall.
I see what's going on here. Give me 1 second. All right, here we go.
Drosta effect. I love it.
Better?
Okay.
Yeah.
Beautiful.
I would say so. Okay.
Cool. So
ahead and drop
I
it
just had
down.
a few demos I want to share with you all. This first one is basically something I built with Rerun a little while back that I thought was super cool because it does a few things. The first one is this basically integrates directly with, speaking of Hugging Face, Gradio from Hugging Face, right? And so this was originally a paper from, I believe it's ByteDance, where you are able to take a low resolution depth map from, in this case, it's
I think
Pablo,
we're seeing
Pablo, we can't. We're just seeing you now. Yeah, but we can see your
we're seeing
screen
a different
behind you.
We're seeing a different screen. Yeah, I think
me
you need
see.
to.
What about now?
I'm seeing your the window for restream, and instead of the demo window, I think you just need to choose a different.
Yes, let me try. Let me try this then. Let me try sharing the entire screen. How about that? 1 second. Let's see.
Computers were a mistake.
Yeah. What about now? Is this better?
Yes, we can see it. It's excellent.
Okay, perfect. Sorry about that. So
it's all good, man.
Basically, this is an old paper from ByteDance called Prompt Depth Anything, which basically takes a low resolution LiDAR map. In this case, it's from an iPhone. So iPhones have these little time of flight sensors on the back that produce, it's like 256 by 192 depth maps. So they're super low resolution, but they're metrically accurate. So they're super helpful. And the idea is you take this this map and then you throw it into a modified version of depth anything that they called prompt depth anything, where you're using this to basically do depth map super resolution. And so what I did is I basically integrated a little UI with Rerun and Gradio that allows you to put a zip file of your iPhone's data collection. And in this case, it was a Polycam scan. And so what this does is you take this Polycam scan that has the camera intrinsics and extrinsics, and it basically does a super resolution of that depth map. And so what you can see here is me scanning my room. This was from an old house that I had, and generating these super high resolution depth maps. So here you can really see a great example of that. So this is the original depth map that was generated from the iPhone, and you can see I think I like super resed it. I just did like a linear interpolation to make it 1024 by 768. But originally it's a really, really low resolution depth map that you can see, right? You can see all the kind of artifacting there. And when you feed it into the network, then you get this nice, crisp, high resolution depth map after the fact. And you can really dig into, it really, especially on those like boundary surfaces for a plant like that, you can really see it. On top of that, I basically take those depth maps and the the camera parameters that were generated here, and I fused them into a mesh using I think it's Open3D TSDF user. And so you can basically watch your room appear, into existence in semi-real time. So this is running on my, I think it's a 5090. So it's not quite real time, but it's really, I feel like it's a super cool visual of being able to stream back and forth between these two things.
What's the FPS?
I think it was like 2 or 3 FPS, something like that.
Yeah.
So it's manageable.
Yeah.
The other cool thing that Rerun really lets you do here that I wanted to show is the depth maps aren't the only things that I basically get from the iPhone, right? There's another example of these confidence values. And what I can do is I can basically generate a new view here. And you can see I basically generate a segmentation map. And the segmentation map, basically the blue areas are where the network thinks it's a very high confidence. Green is kind of medium confidence, and then red is not very confident at all.
Mhm.
And that's just directly included here. And I use a blueprint to basically make it look nicer. So we are only seeing these two things, but this is directly inside of this, time-aligned recording that was generated. And so you can kind of see here what that looks like. And so that's one of the demos I thought was really cool. And I think the fact that you can integrate this into a Gradio app is super helpful because you don't want just visuals. You want to be able to interact with it. In this case, it's super simple, right? There's a few settings and things that you can change. For example, the max resolution or the depth range. But I thought this visual is super, super cool. So I just wanted to share it with y'all for this first one. So that's one of the demos I wanted to show you. The main thing that I've actually been working on recently.
Super magical there. Great demo.
Thank you. Yeah, it's a very cool one, and the Rerun viewer does such a good job with, especially with depth maps. I feel like depth maps look just amazing in 3D like this. There's not a whole lot of, it's really hard to usually get something like this. But I think Rerun makes it super easy. Cool. So the next demo that I wanted to show, actually, I also wanted to show maybe a little bit of the code base as to what that actually looks like for integrating this. So basically in Gradio, right? And I don't know, is this text big enough? Can you guys see this okay?
Bigger would be better.
Yeah, bump it
let's
up
see
a
if I
little
can
bit
make
if you
bigger.
can.
Yeah, I should be able to. Give me 1 second. Okay,
Yeah.
how about there?
Yeah.
Great.
Yeah, so usually in Gradio, right, super simple, you have this sort of blocks API, right, that defines the application. And, here you can define like the upload, the buttons, right? And the main thing with Rerun, it's just a very simple kind of viewer object, right? And this Rerun object is basically just a pip installable like extension to Gradio, which is right here, this Gradio Rerun. And the Rerun team did an awesome job with this integration. And so it's just this very simple, viewer object. And then whenever you want to return something to it, which is what I was doing in this example, it basically streams that back to the viewer that you can kind of see here, right? It's just an output. So you're basically just returning the bytes directly to the viewer. And that's how you get this really cool visualization. So I just wanted to show how kind of easy that is to do. So let me go to the next demo that I think is really cool. So that was this prompt depth anything. This was just me, playing around with a really cool paper that I thought at the time. So the primary thing that I have been working on is how do we use the abundant amount of kind of human data out there to train robots? Because robotics is data constrained, in my opinion, right? The reason things like, ChatGPT or Tesla Full Self Driving works is because they have just enormous amounts of data to train their models with, and that doesn't really exist for robotics, not in the traditional sense. And so the thing that I'm building with the company I'm trying to start is how do we go out and collect this data at a reasonable scale? And so let me see if I can show this example. So basically, Rerun has let me ingest some of this data into this ROD format that Nico was talking about. And in this case, if I can show you here, it's a bunch of time-aligned videos of somebody performing an action. In this case, I think they're like picking some fruit or something like that. And each of these videos are actually different FPS between the what I call exocentrics or third person, so that the ones that you can kind of see here, where the cameras are kind of looking at the person. And then there's this other one that's the egocentric, right? And so if I click into, for example, this exocentric, you can see that this video here is 1280 by 720. And on top of that, it's the average FPS is 30 FPS. Whereas this video here, this comes from an Oak D camera, the ultra wide one with the SLAM cameras on there. This has a different FPS. And so this could cause a lot of issues down the line if you don't think about this and like the time alignment. And this is something that Rerun really excels with. And so basically, we go out, we collect this data in a synchronized manner. So you can see it all runs, in real time, synchronized together, super important. And then I have this pipeline here that generates a full 3D reconstruction with human poses. Let me click on this and hopefully it will run. And so, okay, so here it is. So this was the raw data. So those synchronized videos, and that's it. It's only videos. I'm not collecting anything else. I could collect like camera calibrations and IMU data, and that's the plan to do at a later point. But for now, just for the sake of simplicity, we're just using the videos. This basically gets put into a neural network that outputs the camera parameters and the depth maps per view. So here you can see basically exactly what that looks like. So we have the 4 cameras, the 3 exocentric ones that you can see here, and then the single egocentric one. And from those 4 videos, we generate the calibration. And then once we have the calibration, we're able to do basically real-time pose estimation in 3D per view.
Very cool.
Very cool.
Yeah. So
and kind of Halloween-y as well with the disembodied face and hands.
That's right. That's right. And this works super well because you can imagine the complexity, right? This isn't just a single video, or I'm sorry, a single frame that you have to worry about. This is multiple videos that have to be time synchronized, spatially synchronized. That can get really complicated really fast. And having something like this to be able to kind of visualize, okay, we have the 2D key points that get projected back from this 3D estimation. And you're able to kind of click on each one and see exactly where it is, the color. So I color graded the key points based on their confidence values as well. So I was able to not just have like, oh, this is the 3D location of this key point, or the 2D location in this case, right? But also how confident is the network in what this key point is doing over the entire thing. And so you can see the 133 key points, the average confidence over the entire specific frame, right? And that changes depending on which frame I'm using. So that's this part. So I think this is super cool. This is the fully automatic pipeline that I basically built myself. But the problem is, neural networks will commit mistakes. So this is the perfect example, right? You can see here that like the key points aren't quite aligned with the hand, right? It's close, but it's not quite right. And so I have to have some way to update some of the errors that come so that I can make the data flywheel that Nico was talking about, right? You have to be able to have both data and model and quickly iterate on that. So as part of this, I also went and built a different Gradio app, which I will run right here. And so this will run another implementation of this thing that I basically built. And this is basically an app that allows me to fix any errors inside of these predicted, annotations. Oh, give me 1 second, sorry, clicked the wrong thing there. So let me grab, so this is basically the output that our default. So this is the original one that's completely uncalibrated. This is the one that was annotated by that neural network, which is like a conglomeration of different neural networks doing different things. And so I basically, drop this file in here. It's trying to ingest this here right now. There's probably a better way that I can do this. This is just, I did this in a suboptimal way, but you can see, okay, we have this saved data that came from that directly here. And, I can scroll back and forth through the code to see what these things look like over time, right? So I want to do maybe an example of me trying to fix a bad detection, if it will cooperate with me. Sometimes the decoder does not want to decode frames.
It's doing a lot in the web browser there.
Yeah, that's the really cool thing of being able to. Rerun made this little WASM module that you can just directly embed, and that's what this whole thing is. And do this. Let me maybe reload and see if that will fix it.
Brave
It in
live
again.
demo.
Yeah, never goes as expected, does it? Okay, let's try this again. All right, so let's just pick a random frame. I'm gonna guess. Okay, so here's a great example, right? You can tell that this hand is not good. This is really, really bad prediction that was generated by my network. And so I can tell this is the right hand. I can just, basically generate a bounding box myself. And so you can see, okay, here's my bounding box. And if I hit confirm bounding box, this basically calls a neural network to do hand annotation on this very specific thing. And as you can tell, that looks much, much better, right? That annotation is significantly better. And Rerun made that a lot easier to do. So you can think about it as kind of a 3-stage pipeline. There's the raw data acquisition that allows me to make sure that the data is actually synchronized and working as intended. There's the fully automated pipeline that takes this raw data and converts it into useful robot training data. And you can imagine it's not quite there yet. This is something that I'm still working on, but I want these 3D key points to be joint angles, right? Because you can imagine the action state is what's the robot would basically predict, right? So we go do some inverse kinematics and basically generate joint angles as to like how the person moved their hands. And then you need to have some way to fix errors in the network because it's not always going to provide good predictions. And so something like this label app basically allows you to do that. And so this was a recent thing that I built to kind of show this. And I also wanted to show kind of the code as to what this looks like. So same thing, right? We have this viewer right here. Is that big enough, by the way? I don't know if this one changed.
Yeah, that's better. Thank you.
Yes. So again, same thing. You have this kind of viewer. The thing that's changed here is now you have these callbacks, right? So for example, we want to be able to track exactly where in time we are when we're scrubbing through, so that when we generate the bounding box, it doesn't just generate it at a random frame, right? We want it to be at the correct frame. So we basically add this callback that made it super easy for Rerun to do that. And so I have this thing called track time that basically generates. There we go. That basically gets the state of the app that it's currently at. It gets a payload of like the current time step, and then I update that payload to know, okay, the current time is this time in nanoseconds, right? And then return that state, and that tells me, okay, this is exactly where we're located in time at this exact second. So Rerun makes it super easy to do this kind of stuff. There's another callback to basically like register when you actually click. So to allow this to happen, which I believe is in this one here. This is a bit of it's definitely more of a involved app, as you can imagine. I'm trying to build something like this. So yeah, this one right here, which is the same viewer, right? We basically, instead of doing the time change, we're doing a selection change. So when we click on something, this lets us register a key point, and then with that register a key point, you can imagine, we get a payload. Right, we basically iterate through this payload and say, hey, how many selections did we make? We only want a single selection, so if it's more than one, raise an error. If the selection is not an entity selection, because there's more than one kind of selection. And so you can do really powerful stuff here, right? And in this case, for example, I only want to annotate that egocentric view, and that egocentric view has a name of RGB inside of it. And so if it doesn't have that name, then raise an error. And then finally, we end up with this basically selection event payload, which I update and then return back to my app. So yeah, I really think that Rerun has made this just extremely easy to go through the full stack of data collection, fully automatic annotation in this case, and then manual labeling. And so yeah, that's basically the demos I wanted to show. And any questions, I'm happy to answer them.
And being able to step through the data like that is so valuable for us, us mere humans,
That's right.
the non-artificial intelligences out there in the world. So yeah, extremely cool. Yeah, great. Big ups to the Rerun team for continuing to. I feel like every time we talk to you guys, there's
massive
something
progress.
yeah, it's pretty crazy. It's wild to see. So yeah, congrats, Nico and the team.
Thank you. And awesome demo, Pablo. Pretty.
Yeah.
That was really cool,
Pablo.
Yeah. No, yeah, the
Yeah,
team is working super hard, and yeah, I think we're super excited that we get to release all this stuff open source to the community. I'm super proud also of how that's been received, and I think already we've been when there are a lot of things that are not publicly available, but we've been part of a lot of great companies putting out some awesome products. So that's really fun to see, as well as just community and hobbyists and all that kind of thing.
Right. Yeah, definitely. We got time for a couple of questions here. First of all, I have an axe to grind with one of you on YouTube. We posted a video from GitHub Universe yesterday, encouraging you to come to the booth. And somebody, I was going to bring it up on screen, but I couldn't find the comment now. But somebody commented that I looked like Temu Jake Gyllenhaal, and that's not true. I'm very clearly Wish.com Jeremy Allen White. So no thank you, but thanks for the follow, however. We've got a couple questions here, the first of which this one's from Zoom. I think this is sort of a more broad one for perhaps Satya, but I think everyone on the panel here is pretty familiar with OpenCV, so maybe we can all chime in on this one. Over on Zoom, someone asks, as someone who's just beginning to learn OpenCV, do you have any advice or recommendations on how to get started effectively?
Did we plant this question?
No, hey, sometimes the chat provides.
I'm kind of embarrassed to answer this question because it feels like a planted question.
No, it's not. It's not.
Okay. Well, so the best way to get started, we go to opencv.org/university. You will we have a bunch of free courses. One of the courses is obviously OpenCV getting started with OpenCV. That's a short 3-hour course. Don't expect magic from it, but you'll get started, right? So it will help you get started. And then we have, like I said, our courses, the paid courses. And if you're specifically interested in computer vision and OpenCV only, then the course called Fundamentals of Computer Vision and Image Processing, that is a great course. It's not a short course, right? It takes about 3.5 months to complete if you are working 1.5 hours on it every day, right? So it is involved. You will learn the basics of all kinds of computer vision techniques. The only thing that we do not cover in that course is 3D computer vision. But other than that, you will get a lot of foundational material in computer vision. And frankly, it is better than most university courses. I would say 99.9% of the university courses won't even come close to what we have at OpenCV University, the Fundamentals of Computer Vision and Image Processing course. Yeah.
Okay. Yeah, thanks for that. And I mean, our guests, like, is there, do you have any suggestions for folks that are just getting started in computer vision, like online? Where can they find some help?
I don't know. I personally learned so long ago, but back in the day, it's still the main principles. Perhaps like have something cool that you're excited to build, and sort of hopefully start simple and try from there. Definitely with OpenCV.
Little enthusiasm goes a long way. I agree with that.
Yeah,
for sure.
I would agree with that. It's I think having a good course also helps. I actually learned through Udacity. So I'm originally a mechanical engineer, so I kind of taught myself all of this through like online courses and all that stuff. So finding a project that's really exciting is a really, really good way of doing it. And just like having, some semblance of guidance to get you through something is also super helpful. But like building real stuff that like solves a problem for yourself in some way is super helpful.
Yeah, I'm surprised. So one of our students, he was also a mechanical engineer, and he basically during the height of pandemic, he graduated at the height of pandemic. Everything was shut down, and mechanical engineering jobs, they were, remote mechanical engineering jobs were not available at all. So he decided to do this, and finally he ended up in Tesla, right? So which was his dream job. Yeah, a lot of people, surprisingly, from aerospace and mechanical engineering, we are seeing a lot of people transfer, because I'm guessing that, all the matrix manipulation and all those things they already know. So it becomes an easy easy transition.
Yeah, a lot of those skills are applicable. Like the domain knowledge actually transfers from one to the other in some cases. That
And
makes a lot of
especially
sense.
if you go into robotics, right? Because all the mechanical engineering things would be super useful. And if you work on perception in robotics, then obviously computer vision is super useful.
Yeah, and you'd have a big leg up on a lot of the people that are starting fresh because you've got, potentially years of experience using that stuff, right? Knowing about kind of tolerances and servos and blah blah blah.
Yeah, Andy Gallen, who the person I'm talking about, he was able to actually build a self-driving car. I mean, this is just a demo project, right? But he equipped his car with some equipment and used perception. So the car would drive along in a parking lot and avoiding people. Obviously, an empty parking lot, very good test. But it was super cool. That was one of the entries in the OpenCV AI competition, I think back in 2021.
Yeah, I remember. I remember Andy's name for sure. We got a couple more questions here. I think we got a little bit of time left. Let's do. Speaking of Tesla, we were just talking about Tesla here. We got another question from Zoom. So we're looking at that demo there. People were asking, can you take the 8 camera outputs from the Tesla and generate a 3D movie using those outputs with the demo we saw earlier, Pablo?
It's funny. I actually think Tesla's doing exactly this. I just saw one of their updates from, I think it was ICCV, and they're using basically Gaussian splats over time to like generate exactly that, a 3D movie. So yeah, absolutely. And that's where I would want to go eventually. Like, I think, being able to track every point moving through space and time at the same time is like the end goal of the thing that I envision with this. But it's quite a hard problem to do. It's
Right.
non-trivial.
And also, I don't know whether it is easy. I have never done it or tried it. Whether it is even possible to get the camera feeds from Tesla and the intrinsics, etc., the calibration data, or the camera.
Is it locked down? Yeah, I don't actually know.
Yeah.
I think you can get the camera, like the image data, but you're not going to get it at the stream that Tesla gives. I think they use it for like third-party SDKs for like a security app or something like that. But I very much doubt you're going to be able to get the calibration data or like the integrity of the thing that you would need.
Right.
Right. I see. Okay, that makes sense. Thanks for that. We've got let's do one more question and we can call it a day here. I think hey, this one was also not a plant, but it seems very much like one here. I'm doing data science and exploring how OpenCV can help visualize spatial data. Do you recommend any pipeline? I mean, I think Rerun is a great answer here. Like where so I'll throw to Nico here. Nico, where can folks go to get started with Rerun?
Yeah, just go to rerun.io/docs. I think this is a perfect match. So you can easily take OpenCV images and spatial primitives, just chuck them into Rerun, and you're gonna get going. It'll be a couple of minutes, so super easy to set up.
Fantastic, yeah. And our community member Pablo, like any suggestions for other kind of resources that are maybe not officially on OpenCV or Rerun? Like, are there any sites that really helped you out?
I'd have to think about it. I don't know if this is exactly the answer, but actually one of the projects that I really, really like, and I think Rerun uses themselves, is Pixie, because half the battle is just getting started and getting dependencies. And man, Pixie is just so incredible because they have a log file. They'll let you do C++, Rust, Python. It's awesome. I think it's not exactly computer vision per se, but like dependency management can be so painful, and I think Pixie solves a lot of that. So it's pixie.sh.
Pixie.sh. Okay, got it. We've got one more from Zoom, which I'm actually going to pull it in here because this was a really interesting question from Swati, who's a longtime viewer of the show. Can I use, this is kind of a long one, can I use a text prompt, e.g. a cluttered kitchen with a robot arm, to generate both an RGB image and a corresponding depth map with semantic labels, then visualize all 3 layers together in Rerun for rapid prototyping of simulated physical AI environments? Did you get all that, Nico?
Yeah, for sure. I think Rerun doesn't build these models, but there are certainly some really great generative models like this out there.
I think that's
open
what they're
source.
asking, is that can they,
Yeah.
maybe generate something
Oh,
with
yeah.
one of these other models and then just lay those on top of each other using Rerun? It seems like
Yeah,
the answer
super
is yeah.
easy, super easy. And even if you want to use Rerun to debug like the generation as well, if it's a diffusion model, you can even go nuts and log the intermediate states and things like to get real deep. If you're using an open source model and you want to like figure out why the latents aren't like the right thing isn't happening, I've spent a little time doing that myself.
Okay.
Couple years ago, and that works super easy as well.
Very cool.
Yeah, so you can create the image or a video using pretty much anything, right? Use Vivo or and then the second piece was the depth map. For the depth map, you can use this thing called Apple has Depth Pro, and Pablo also mentioned another one.
Depth anything.
Yeah, so I don't know which one is better. We have been using Apple's Depth Pro, that paper implementation. It works solidly, right? So I don't know the comparison between the two, but either one would work. So you can get the depth map from there, and the rest is Rerun.
Yeah. And on that note, the rest is Rerun. On that note, I think we can call it a day here. Any final words for the folks out there, Nico or Pablo?
No, super. Not other than like thanks for having us. Excited to be chatting to the computer vision community here. Definitely go check out Rerun, rerun.io. See if you want to learn some more or reach out to us on social, wherever. And looking forward to hearing from you.
All right. Yeah, Pablo?
Same on my side. Not a whole lot to add, but definitely go look at Rerun. It's been a massive unlock for me and all the things that I'm doing. And I appreciate you guys letting me on here and showing me some demos.
Yeah, man. Thanks for joining us. Satya, you want to go ahead and take us home?
Yeah, thank you so much. Thank you, our entire audience. Thanks for showing up every week on Thursday. We really appreciate that. And thanks, Nico and Pablo, for this excellent show. I learned a lot. You guys have, Rerun has made a lot of progress, which frankly I did not know about. So this demo was excellent. As you know, that we also have a consulting company, and we need these tools all the time, and we use some of these tools that we talk about in our on this webinars. So and as always, thanks Phil Nelson. Nothing went wrong, and it's an excellent. It was an excellent episode.
As the producer, I can note 5 or 6 things that went wrong, but I'll accept that compliment. Take care of yourselves out there, folks. We've got another great episode coming to you next week with, I believe, Alexandra Roberts. Yes, we're going to be a professional in quantitative medical imaging and MRIs, magnetic resonance imaging. We're going to learn a little bit about how computer vision is affecting those industries in medical and imaging. And so super excited for that episode. Same bat time, same bat channel, 9 a.m. Pacific. Take care of yourselves out there. Take care of somebody else if you can, and have a great day wherever you may be. We'll catch you next time. Adios.
Thank you, guys.